interrupted by announcements here in a minute, but we'll go on and get started and use the time. Now, looking at these here, describe each transformation of the quadratic function. So 1, 2, or 3, is there any one of those three you want to look at first? 1, 2, or 3? So if we look at number 3, the value outside of the parentheses right in front of it is either going to tell us one of three things. It's either going to be a vertical stretch, vertical shrink, or a reflection across the x-axis. Now, because it's negative, it's going to be a reflection across the x-axis because it's negative. If there had been a number there, whole number or decimal, it would have told us if there was a stretch or a shrink. If the number is greater than 1, it's a stretch. If it's between 0 and 1, it's a fraction, it's a shrink. It doesn't matter if it's positive or negative. The negative only tells me if it's a reflection across the x-axis. If it's a negative, it's a reflection across the x-axis. Now I'm going to move inside the parentheses. So here we have a -4, yes? So it's the opposite direction of what we think. So since it's negative, it's not to the left, it's to the right. So this here would be right 4. And last but not least, the number outside would be up 2. Because the number outside the parentheses is up and down, And that's all we have to say for this one here, because there's a negative outside those parentheses, it's a reflection across the x. And the 4 inside, the x minus 4 tells me it's 4 to the right, and the plus 2 tells me it's up 2. And that's all we have to do for this one here. Questions on this here? Now let's look at number 5. Because the way we go about doing or looking at number 5 is going to alter how we look at this. Because on the answer key, I believe it says, it talks about the reflections first. Yes? So if we talk about the reflections first and describe them first, so 0.7, I have to pull that negative out from the two numbers inside the parentheses. If we talk about the reflection in the y first, if we say that it's a reflection the x-axis, I'm going to do them both, and and y-axis, because the negative inside, negative front of x inside the parentheses is across the y. The negative outside the parentheses is across the x. So if I talk about the reflections first, I have to do this. Then we can talk about the vertical shrink of 0.7, the right 4 and down 1. We have to worry about it that way. Now, if I talked about the horizontal and vertical translation, moving it up, down, left, and right first, we wouldn't have to do that. But there's not going to be a reflection in the y-axis on the test. There will not be a reflection in the y-axis on the test. Because the only way we have a reflection in the y-axis is if the negative is with the x inside parentheses.
So whenever it's a negative,
yes, and if it's in front of the parentheses or with x. Now, if it's just negative x squared, this here is across the x because it's not inside parentheses. But we won't have a problem like this come up on the test because, again, we have to manipulate the equations to really see what is happening. Any other questions on describing these transformations? We need to see another example of one of these. Yes? No? We're good? Okay. Find the vertex and axis of symmetry. Not y equals x equals. So we have the equations from yesterday. Now for vertex form, I'm going to just start off with number 6. The vertex is h comma k. And just looking at this here, h and k are right there. H is inside the parentheses, k is outside. So for here, what is the value of h? So we have -2 inside. Now the axis of symmetry is x is equal to h, and we said h is 2, yes? It didn't matter what a was? Did it really matter what the value of a was, this number out front? No. That number could be ugly. It could be 97 over 2 billion. It doesn't matter what it is because the values of h and k, h is inside, k is added to the back end, and that's it. That's all we have to do for this here. Now, if it's in standard form, the vertex is negative b over 2a, comma f of negative b over 2a, and the axis of symmetry is x is equal to negative b over 2a. So we'll look at number 8. So to find the vertex, I have to do negative b over 2a first. So what's the value of b for this here? 2, because we have a, b, and c over 2a. Now what's the value of a? Do we have a number written there? So what would it be? 1. When we're plugging in for negative b over 2a to find the vertex, we do not plug variables in. When we do this here, b and a will never contain x or x squared. When we plug this in, b and a will never contain x or x squared. B and a for this here are just numbers. And when we simplify this here, we will get negative 1. So the x value of the vertex is negative 1. Now, if it worked out b was negative, again, we'd still plug it in. We'd plug it in as negative, negative, whatever the number is. Because, again, the sign in front of b goes with it. Here, the sign in front of 2 was positive, so it came in as positive 2. We have negative positive 2, which is just negative 2. So you have to take the sign with it. Now, what we do next is we plug it into the function. And at this point here, I would plug, well, this whole thing into the calculator, do parentheses, negative 2, or negative 1, close parentheses, squared, plus 2 times negative 1 minus 1. Type the whole thing in. Type it in and let the calculator tell you that it's negative 2. And we already found negative b over 2a, so that gives us the axis of symmetry. So if you notice on these here, when I'm finding the vertex and axis of symmetry, those values are the same, yes? The x value of the vertex and the axis of symmetry are the same. They're going to be the same. Any other questions on this here? Are there any other questions on 6 through 10, that any of those that y'all want to look at? Number 2, yeah. So this is in vertex form, so we know what the vertex is. What's the h value? Almost. Negative 1. What's the value of k? Axis of symmetry would be x is equal to, because since 1 was positive inside of the parentheses, it comes out as negative. We switch the sign because we're pulling it out of the parentheses. And since there's nothing being added to it or subtracted from it, it is 0 for k. It's 0 for k. And x equals h, since h is -1, we have our answer here. Any questions on these here so far? All right, let's look at the next set. Any one on 11 through 15 we want to look at specifically. 11 through 15. 11. Focus, axis of symmetry, and directrix. I'm going to also do the vertex. Because as we looked at the equations yesterday, y equals 1 over 4p times x minus h squared plus k. Vertex is h comma k. Focus was h plus p comma k. Thank you. Directrix is y equals k minus p, and our axis of symmetry is x is equal to h. The other equation we had was x is equal to 1 over 4p times y minus k squared plus h. Vertex is still h comma k. Focus is h plus p comma k. Directrix, x is equal to h minus p, and axis of symmetry is y is equal to k. Now looking at this here, what is the values of h and k? Zero. I don't have anything being added inside of the parentheses, and I don't have anything being added or subtracted on the end. Yes? Nothing inside parentheses added or subtracted. Nothing on the end. So they're both 0. But I do know that this here, this negative 1/12, 1 over 4p. So the first thing we would do is we'd multiply both sides by 4p, because those two would cancel, leaving us with 1. We'd have negative 4p over 12. Now 4 over 12 are reduced to 1/3, negative 1/3. And now what we need to do is we need to multiply both sides by negative 3 to get p by itself, because these two will cancel, and I get p is equal to negative 3. Now the vertex for us is 0, 0, because the values of h and k are both 0. So that worked out nicely. Now the focus, so when we look at y equals, the focus is h comma k plus p. Well, h is 0 plus negative 3 is negative 3. Directrix, y equals, well, 0 minus negative 3. It'd be positive. It'd be positive. And last but not least, the axis of most likely on the test, no matter which one it is, even if the vertex is 0, 0, the values of h and k are 0, 0, you still might be asked to find the vertex. They might be asked to find all of this, no matter what the equation is, as long as it's one of these two forms. You're probably going to be asked to find all 4. Questions on this here? Questions on this one here? Okay. Let's look at this one here. Now, this one and the last one kind of work the same way. We need to get the variable without an exponent by itself. We need to get the variable without an exponent by itself. So here I see that x squared and y are both on the same side, so I need to move. It's going to be easier to move the y over to the other side. Because what I can do is I can add y to both sides and get 8x squared equals y. I just added it to both sides so that I can move it from one side to the other. Oh, here again, the values of h and k are both 0. And I see that 8 is going to be equal to our 1 over 4p. So what do I need to do to both sides? I need to multiply both sides by p. Because 4p and 4p will cancel.
Wait, how'd you sure to the x and
Oh. Well, this here lines up with our 1 over 4p, so I know that 1 over 4p has to, when I plug p in, give me 8. Because when we plug the value of p in, it will give me 8. When I plug in 0, 0 for h and k, it'll simplify everything else out. So this is the only spot where p can appear, will appear. So since I know plugging in p will give me 8, I set it equal to it, because I know 1 over 4p should give me 8. So now we're going to find the value of p by first multiplying both sides by 4. And here we get 32p. And lastly, what do we need to do? We need to divide both sides by 32, which tells me p is equal to 1 over 32. Any questions on how we got the value of p? Now the focus, again, for this one here is h comma k plus p. Well, h is 0. Well, k plus p, well, 0 plus 1/32 is just 1 over 32. And we get negative 1/32 on the second one because 0 minus it, since it's positive, is going to be negative. And if you need to write those out for like the focus, saying 0 plus 1 over 32 is 1 over 32, okay? 0 minus 1 over 32. For these here, to go on and write them out so you can see what they are, do it. Go on and write it. Write it out. Because when we calculate those in, we're plugging in h and k. We're plugging in those values. So if writing them out somewhere on the paper helps you find that this here goes here and this one here goes here, that's fine. Do that. Do that. Write them out. Any other questions on these here? Won't show up. Won't show up. Because again, I excluded those from the homework assignment the other day, focus and directions. I told you not to do those. Again, they're not going to be on the test. So let's look at this one. Well, we can look at this one here. Because what is the vertex? It's what? What values? h and k. Because the vertex is always h and k. Now, when I look at the focus, I'm trying to see which number changed, the first one or the x changed. So when I look at the equations, here the x value doesn't change because it's h and h, k and k plus p. So the y value for this one changes. So it's not that one. When we look at x equals h plus p, this one the x value changes, yes? So that means for this problem, I'm going to be using x is equal to 1 over 4p times y minus k squared plus h. So I would just write that formula down just to start with, because we have h and k already. And this one here is h plus p, comma, k. Well, we know the values of h and k are both 0 because it told us that in the vertex, yes? So negative 10 is equal to h plus p, or since we know h is 0, it'd be 0 plus p. So negative 10 is equal to, so because h and k were both 0, it kind of simplified this a little bit for us. But now we can plug these values in, because we said x is equal to 1 over 4 times negative 10 times y minus 0 squared plus 0. Well, this would be negative 1 over 40. Everything else actually cancels out. It simplifies out. Because y minus 0 is the same as just y, and we have it squared, so we can drop those parentheses. And then we don't need the plus 0. Any questions on this here? Yep, so we just need to take each step one at a time. We'll come back to a type like this using the directrix on the next step. We're going to do one of these here, so I'll do 20 just since it's the first one that came up. So when we look at this here, y equals 1 over 4p. H is inside, k is, so here h is, k is 2. Since 3 was negative inside the parentheses, it comes out as positive. And then whatever is outside, so the value of k is just whatever it is. Now to find the value of p, because the 1/8 lines up where 1 over 4p should be. So we'll set it equal to 1 over 4p. Then just like we did before, we're going to multiply both sides by 4p. So 4p and 4p will cancel, leaving us with 1. Here we're going to have 4p over 8. Well, 4p over 8 will reduce to p over. And last but not least, we need to multiply both sides by 2. We're doing the opposite because they're dividing here. We need to multiply. And we get p is equal to 2. We get the value of p is 2. Any questions on how we found h, k, or p? Any questions on any of this here so far? So for here, since we have x equals, now we said the vertex was 3, 2. 3, 2. That's the vertex. Now the focus for this one here is h plus p comma k. The value of k is 2, and we can also fill that in on the axis of symmetry, because we can fill in every spot that just has k, and that'll give us those answers. Now the focus in directrix, am I good to erase this here? Okay. The focus is h plus p. Well, we found the value of h was 3, and the value of p was 2. So 3 plus 2 gives us 5, and that's our focus. Now the directrix is h minus p, so that'd be 3 minus 2.
Are we doing the y equation?
Yeah, sorry, I got them flipped. Thank you. So this should be y, this should be x, so this is 3. Thank you. So this here should be, the 3 is correct, so we're doing k plus p. So it's 2 plus 2, which is 4. Thank you. And this would be 2 minus 2, which is 0. So again, like I've said several times in here, make sure you're looking at the equations. It's very easy to get these flipped. It's very easy to get these flipped, like I just did here. So making sure that you're writing down the correct ones, because I copied down the wrong one, and I would have gotten that wrong. So always referring back to these here. So having these down is going to be important, because you can look back to them and use them. And you need to look back at them and use those there. Questions on these here? Any questions on anything we've done so far? Do we want to look at another type of this here? Yes? Do we want to look at 21 or 23? So again, when we line these up, since I have y equals, the h value is inside, the x value, or the k value is outside. If it's x equals, the h value is outside, the k value is inside. So it does flip. It does flip. I don't think we've done. So here, we're going to go back to 23, but k would be inside, h would be outside. So we've got to be paying attention to that. So looking at 23, the value of h here is 3. The value of k is 1. H is inside, k is outside. And since the value inside was negative, it comes out as positive. Since the value inside was negative, the value for h was negative inside the parentheses, it comes out as positive. Now the only value we're missing is p, yes? Well, I notice that 1 over 4p lines up with the 1 over 16, because that's where p lines up. The 1 over 4p matches up with this equation here. Now the first thing we're going to do here is what, after we set it up? We're going to multiply both sides by 4p. Because this 4p and 4p will cancel, leaving us with 1 is equal to 4p over 16. Again, when we multiply a whole number by a fraction, it only multiplies with the numerator. Now 4 over 16 is going to reduce down to 1/4, so we end up having p over 4. Not by itself, we're going to multiply both sides by 4. Because 4 over 4 will simplify, leaving us with p is equal to 4. Any questions on this here? Any questions on how we got to this here? Any questions on how we got to the value of p? Since here we have y equals, so we'll have x, y. This is here. Because we had 3, 1, 3, 1, 4. Now the vertex would be, the focus is going to be 3, and here we have h plus p, not h, k, sorry, k plus p. K plus p, I don't know why I keep writing h. K is 1, p is 4, and 1 plus 4 is 5. Questions on how we're getting this here? Any questions on any of this here? We good with this here? Now the directrix is k minus p. Well, k is 1, so we'd have 1 minus 4, which is negative 3. And axis of symmetry is x is equal to h, so it'd be x is equal to 3. Any questions on any of this here so far? Are we good with all this here? Yes? Any questions on any of this here so far? So let's look at 24. Now they gave us the vertex and the focus. Now the vertex I know is always going to be h and k. So no matter what the equation in, h is 7, k is 3. Because it tells us it. It tells us right here that this is what the equation is. So what we need to find next is the value of p. Yes? We need to find the value of p. Now, when we look at this here, we want to see what changed from the vertex to the focus. So 14 changed, so that means I'm using x equals 1 over 4p times y minus k squared plus h. And the 14, this lines up with our h plus p comma k. So we're saying that h plus p is equal to 14. Because that's what it is. That's what the equation told me, that the focus for this here is h plus p comma k. It told me the h plus p value is 14, and k is still 3. Now I know the value of h. H is 7. So once I set that up, I need to just get p by itself. So I'm going to subtract 7 from both sides and get p is equal to 7. So now I have the three values. I have p, h, and k, p, k, and h. Any questions on how we got those values? Any questions on how we got any of these values here? So what we're going to do next is we're going to plug these in, because we have x is equal to 1 over 4 times 7 times y minus the k value is 3 plus 7. So remember, when it's x equals, k is inside, h is outside. When it's x equals, the k value goes inside, h value goes outside. Now we just need to simplify a little bit. If you need to, type this into the calculator, do it. The graphing calculator, the yellow calculators, either one of these will simplify this to 1 over 28 times y minus 3 squared plus 7. And this is it. Since we didn't have any double negatives, so inside the parentheses we didn't have y minus negative 3, we don't have to change anything there. This is just the equation. We had to find the values of h, p, and k. And once we found those, we plugged it into the equation it matched with, and we're done. Any other questions on this here? So we're good with that there. Vertex and focus, vertex. So this is the last type that we need to look at, is passes through, and I'll put those equations up there in a minute. But since this gives us the vertex and a point, we're using the vertex form. Y equals a times x minus h squared plus K. Now the vertex gives us the values of H and K. And when we're finding the equation given the vertex and a point, I plug the vertex in first. That's the first thing I do. I plug this in. Because what I'm trying to find is the overall equation. And I get this here. Now I notice the only thing I'm missing still is the value of A. I'm not finding Y or X. Those are going to be a part of the equation. I need to find the value of A. And that's where the point comes into play. Because to find the value of A, what I'm going to do is I'm going to take that point and plug it in. So Y was negative 24. X was 0. I plug that in, and when I plug that in, because it is going to make it true, when X is 0, Y will be negative 24. It just works for that equation. So I plug it in for X and Y respectively. And then we're going to solve. Now, if you want to type in the calculator parentheses 0 plus 6, close parentheses squared, you can do that. And it'll give you your answer. Or if we do it in individual steps, well, 0 plus 6 is just 6. And 6 squared gives me 36. Now to get A by itself, I'm going to add 12 to both sides, which gives me negative 12 equals 36A. And at this point here, I'm going to divide both sides by 36 and get that negative 1/3 is equal to A. And once I find that value, I just plug it back in for A. I plug it back in for A. So we plug in A, H, and K. A was negative 1/3 because we worked it through and found that it's negative 1/3. And plugged in H and K and got this here. So we used it to solve for the value of A and then plugged it back in. Any questions on this here? Any questions on any of this here so far? I know I went a little speedy through that, but I want to make sure I get this one and one of these here. Because the x-intercept formula is this here, and our intercepts are the values of P and Q. It tells us P is negative 16 or Q is negative 2. It doesn't matter which is which. We just need to pick one of them as P, and we need to pick the other one as Q. And what we're going to do is we're going to plug that in. We're going to plug it in for the values of P and Q. So we get Y is equal to A times X minus negative 16 and X minus negative 2. We plug those in. Now we have to simplify a little bit because we don't like negative negatives. Because if I have a minus and negative, it turns into positive. So we're going to rewrite it as plus. When we have that minus and negative, we're going to rewrite it as plus. Any questions on this here so far? Now we notice again, just like the last one, the only thing we're missing is the value of A, because if I have the value of A, I have the overall equation and we're done. So what we're going to use again is this point here. I'm going to plug negative 18 in for X. And the value of Y is 72. So I plug that point in. I plug negative 18 in for X. I plug 72 in for Y. Now here, what's nice about this one here is all of this here. You can type straight into a calculator. You can do parentheses, negative 18 plus 16, close parentheses, open parentheses, negative 18 plus 2, close parentheses, hit enter, and it'll tell you exactly what it is. The calculator will calculate that entire thing. Now, if you don't use a calculator, negative 18 plus 16 is negative 2. Negative 18 plus 2 is negative 16. Negative 2 times negative 16 is 32. Wouldn't be equals H, it's 32A. Because when we multiply those together, negative 18 plus 16 is negative 2. Negative 18 plus 2 is negative 16. We multiply those together, we get 32 because a negative and a negative make a positive. And then we're going to divide both sides by 32. It would be nice if it was 36 because that would reduce it to 2. But this here reduces to 9 over 4. And our original equation is y equals a times x plus 16 times x plus 2. And now that we found the value of a, it's going to be 9/4 x plus 16 times, and that's our equation. So it's very similar. It's very similar. Hopefully you notice that the similarity between the one we did before this one and this one here are almost the exact same. It's just we have a different formula that we're using for each one. We have a different formula we're using for each one. All right, so I think the next one is vertex, finding the equation, and that is it. So that is everything we are covering on this review sheet that will be on the test. Okay? Any questions on any of this here? Any questions on any of this here? So again, you can have your review sheet on the test. I would highly, highly, highly encourage that you have all of those formulas written down. Because we already saw today, it's very easy to flip these. Yes? I flipped the two formulas. I flipped them around. It's easy to do. Look back at them as a reference to make sure you're plugging in things to where they are supposed to be plugged in. And having examples written out would be good. If you, for some reason, didn't have time, work on it this afternoon. This video will be online on YouTube before the end of next hour. So you can go back again and re-look at it if something didn't make sense or you got stuck. Or come ask me in Flex. Come to Flex, and I will go over this again.